Before we start, just a quick reminder about the setup in Moodle. So this is section 1 of the course. You'll notice a couple of things. One is that I've added some videos. So I added a video of Tuesday's lecture. After today's lecture, I'll go back to my office and make a video for today's lecture. So if you're like that student who emailed me about being sick, you can just skip that part and wait till later in the day, and as you're sick in bed, watch my video instead of Netflix. Okay? So like I said, it'll get posted here. The notes are up there already. Your Tuesday work, so instead of coming to class on Tuesday, was to watch this video using the SDA website, and if you haven't done that yet, you still have time. But that was the expectation for the Tuesday part of class that you did not come to. Okay? Again, hybrid class, half online, half in person. Any questions about Moodle before I start my show? Of course not. Okay. So today's lecture, this is what we're going to do. We're going to figure out why it is that we need to learn statistics, how it's going to be helpful to us, and start with some vocabulary of concepts that we're going to use throughout the class. So the first step is, when I say statistics, what do I mean? I don't mean math, right? I'm not talking about geometry or trigonometry or quadratic equations. Statistics is different. It's a branch of math. But you will find statisticians throughout the social sciences that are something else. So I'm a political scientist by training, but I'm also a statistician. People in sociology, psychology, marine science. Statistics is a way of doing science. It's the science of collecting, organizing, summarizing, and analyzing data. So the key word for me in this sentence is the idea of what we're going to analyze, which is data. We analyze data to answer questions. That's a big part of it. I guess I'd say to answer research questions. And or draw conclusions. And it really depends upon the types of questions you're answering, whether or not you're trying to make a policy recommendation or reach a conclusion about a subject, whether something occurred or not, or a problem exists. The textbook has a slightly different definition than mine. Statistics is a branch of math, true. So if you go to the math department, not everybody in the math department does statistics. Only a very defined group of people do. So it is a branch of math dealing with the collection, analysis, interpretation, and presentation of numerical data. Why do I need to have my own definition compared to your textbook's definition? How are they different? I don't have anything to throw at you if you say the wrong answer, so. How are they different? What's Howard missing that I think is important? Yeah. So Howard's definition tells you what it is, but my definition answers a bigger question. Why do this? Why learn statistics? He tells you what it is, but my definition tells you the why. Why are we doing this? It's not. Statistics is not a type of math that is useful in your daily life. Remember, the criticism against math is always saying, well, I'm never going to use this. Well, I use the Pythagorean theorem all the time. A squared plus b squared equals c squared. And you know when I use the Pythagorean theorem? When I'm walking someplace. Because I'm always like, oh, I'll just take the hypotenuse. Because that's the quickest way to get somewhere. Or if I'm doing something with wood and I need to draw a line, I have a speed square. Speed square just uses the hypotenuse. It's Pythagorean's theorem. You can do rise and run of steps or other things. If you want to try to do pitch on a roof, for example. Statistics, it's not like when I go home and my family asks me, what are we doing? I run a regression model and say, well, we got an 89% probability of this. We don't use statistics in our daily lives. But we use it to draw conclusions, to answer questions that we might have. So when do I use statistics? I use it in my research. When I'm trying to identify why something has happened, or to explain how people make decisions. And I think that's the important part of differentiating statistics from math. Because remember, you all think you're bad at math. But statistics isn't just math. It's something more. The other reason that I think we should be taking this as your math core class, I think statistics is useful for you, is the idea that we rely on statistics when we make decisions without really even knowing it. So we rely a lot on social science research without understanding where it came from or how they arrived at that conclusion. I have a colleague that just had a baby. I've got 2 kids. Been there, done that. Like, whether or not your child should be smiling at 2 months old, dude, doesn't matter. But it's what he wants to talk about. It's like, okay. He's thinking about measuring his child against the progress that children are supposed to make. And when you take your kid in for checkups, they do things like weigh and measure their height, and they give you a percentile. That's all statistics. We'll actually learn how to do that in this class. Not the measuring babies part, but the percentile part. It's influencing him. He's talking about it. The media helps us make decisions by telling us how we should live our lives. And so I like to sort of collect these headlines as I see stories and save them away. So when we make a decision, you're a college student. The reputation of college students, not so good. All you want to do is party. Should I drink? Well, I've actually had, in my experience, a doctor tell me that I should drink every day for heart health. I should drink a glass of red wine every day. And I'm like, really? I don't really like doctors. Like, I don't go to them unless I'm sick or I need drugs. But there's this guy, and I just didn't like him. You ever meet somebody and you just don't like him? And he's a doctor and he's going to tell me. I'm like, you don't know anything about me. Like, I could be a recovering alcoholic, and you just told me you should drink every day. That might have been a problem. That might have been my grandfather's problem, and maybe that's why I don't drink every day. Like, So we find these studies out there. Usually something that is a guilty pleasure is good for you. So if it's not wine, what else is good for you that should not be good for you? Chocolate. Chocolate's good for you. No. High percentage of cocoa chocolate that tastes like dirt is good for you. M&Ms are not good for you. You eat a handful of M&Ms in order to burn those calories off, you got to do a lap around the track. And nobody just eats like a couple of M&Ms. M&Ms, chocolate's not good for you. What else is good for you that you know is not? Drinking water is potentially deadly. If you drink too much water, your body cannot handle it. And so it just is like, I give up and you die. Yeah, you can die from drinking too much water. But water's good for you, right? You should drink gallons of it a day. No. Actually, what you're doing is ruining your kidneys. Right? Your body tells you when you need water when you get what? Thirsty. You should not force drink. So even something like that isn't good for you. But in a headline, study shows how red wine compound slows aging. And then I have the other one, another study. No amount of alcohol is good for your health, global study says. So which one is it? And how can we have two studies that arrive at different conclusions? How do we know what is true? Which one of these is more important? Well, there's a whole branch of philosophy, epistemology, that studies this idea of what is truth. So for us in statistics, when we run a study and we reach a conclusion, we have to be really careful in how we present the results of our study. Because somebody might say, you should drink every day. Or never drink. Those are some pretty clear absolutes that A, are contradictory, and B, could lead to, well, my early premature death. So when we talk about this idea of truth, we have to remember that sometimes truth comes through investment. We believe something to be true because we believed it's true in the past. That's investment. Not because we know it to be true, because we have previously believed it to be true. Sports is the best way to give you an example of investment. You're essentially rooting for laundry because you're rooting for the team that the person is wearing when they do the sport. Right? You're rooting for laundry. A player joins your team, he puts on the laundry you like, you are invested in that, you believe, therefore, that is the best team. You root for them. You spend your time watching them play. You spend money to go to a place to watch them play. That's a source of investment that you have. Authority. I can't tell you how many times a day I tell my kids, because I said so. Why do I have to brush my teeth? Because I said so. It's a direct appeal to authority. And therefore it is true. Because somebody says something, it automatically is true. Not sure about that. My doctor says I should drink a glass of red wine every day. He's an authority. Sometimes logic gives us the truth. If we reason things out, you have a decision to make in your life, you draw up a pro-con list. You attempt to convince this is the action I should take. I will do this logically. We have the field of game theory. Has anybody ever heard of game theory? There was a movie a decade ago called A Beautiful Mind about the life of John Nash. And Nash, as a mathematician in game theory, devised the idea of what he calls the Nash equilibrium. 4 guys go to a bar, 4 women walk in. Conventional economic theory says that all 4 men should compete for the most attractive woman. However, that will guarantee that 3 of the men will lose, but one of the men, potentially, he could also lose, would receive the largest prize. And Nash is like, you guys are stupid. I'm going to let you all fight for the most attractive woman, and I'm going to go and talk to the other 3 women. So you 3 can compete for 1, and I will go and compete for 3. And the idea became the Nash equilibrium. That's a game theoretic model, logic. We can arrive at what is the best decision for all parties. Later this afternoon, I'm going to teach Marbury versus Madison in my Supreme Court class. The decision in Marbury versus Madison that created judicial review was a Nash equilibrium. It was the best outcome for both participants. Faith can be a source of truth. We can just believe things to be true. This is the way that religion works. We believe it to be true because it is written or spoken to us. This lovely picture up here is a map, and it connects passages in the Bible. So start from the first book to the last book. And any time that there's information in the Bible that is contradictory, we draw a line to connect the 2 spots. So like my headlines on the previous slide where it said alcohol is never good for you and alcohol is good for you, that would be a contradiction and we would draw a line. So if you've ever read the Bible and felt confused, that's why. Because it's full of literal contradictions. And then finally, science. Science as a source of truth. Study shows. Study says. So the idea that the media reports on a study and tells us that the findings say you should act this way. And now it's okay to eat chocolate. Or drink red wine every day. Great for those industries. You can now buy juice boxes of red wine. Like juice boxes. Literal juice boxes. It's not a what? It's not enough? Listen, my doctor said have 1 drink a day, not a bottle. Okay? Like you can have, do I have my daily juice box of wine? Right. They're advertising chocolate bars, the really expensive, thin, dark chocolate ones. They advertise their cocoa content, all right? How much it has in there. You notice Hershey's never got into that? Because there's no cocoa in it. We just make it brown. Make it look like chocolate. So like I said, I collect these headlines. The headlines themselves aren't actually written by the people who perform the study. They're written by an editor. It's today what we would call clickbait. The idea that we want you to read this, and so we'll, phrase the headline in a way that you have to actually click on it to figure out what the answer to the question is. Did the Mets win last night? Couldn't you have just said, Mets win 9-6? No, I got to click on it and go to the link. Study, male jurors more likely to find overweight women guilty. So ladies, if you ever find yourself in jail, use that time to boost your cardio. Harvard study. Again, not only is it a study, it's a Harvard study. There's no such thing as a Harvard study. It's just a study. It just happened to be completed by people at Harvard. Gun control is counterproductive. So laws that prohibit people from accessing guns cause more crime? So there's more shootings when there's fewer guns. Huh? And then sometimes I'm like, I can read a headline and I don't even need to read the study. I agree with it. Friends with benefits have safer sex, study finds. This actually, I don't even need to read that. That just seems logical, right? I do not want to be in a relationship with this person, but I still want to have sex, so I better not have a kid with them. That would make sense to me. They're all touting on either logic, authority, to give us the truth. They never mention any of the actual statistics in the headline. What we're going to do in this class in learning statistics and the methods to test a hypothesis is we're going to tend to focus on one particular type of question. The questions we're going to focus on are empirically based questions. Now, empirical is just a fancy college word for evidence. So if something is empirical in nature, you have observed the evidence. Empirical questions focus on what is happening or has happened. Empirical questions are not hypothetical questions. My kids ask hypothetical questions all the time. And I'm like, that's not a real question. Right? Well, what if they were real? I don't know. Because they're not real. My kids are real, but like the things they ask about, like, you know, what if we had boogie bombs? And I could just, it's a Fortnite thing. So I could throw a boogie bomb at you and you would stand up and dance. Those of you who don't speak 10-year-old Fortnite language. But I can tell you that, generally speaking, people don't like being forced to dance. Because I have experienced middle school gym, where you had to learn how to dance. Everybody remember that? Yeah, you're like, screw this. But my kids haven't experienced that yet. They don't have the observed evidence. The other thing in this class that we're going to lean on as social scientists is the scientific method. The expectation when you use words like study, research, those words are used because you're borrowing off of the reputation of the scientific method. Now, I have to admit, you guys probably were not actually taught the scientific method in high school. So when you butchered like an earthworm or a dead kitten or whatever it is you all cut up in biology class, that was a test to see who the psychopaths are. Like, you didn't actually perform any experiments, and you do not need to know earthworm anatomy ever in your life. We just wanted to see who the weird kids were. That was not the scientific method. In chemistry class, I remember doing titration, which is you mix two liquids together and see what happens. And it's like, it's purple. Then you pour this thing in it and it becomes clear, but only if you had the right sort of balance between the two. That's not the scientific method. That's playing with chemicals. We get to do this as social scientists, and me as a political scientist, we add in extra things on top of the scientific method. So we add in something like politics. Politics is often framed as a zero-sum activity. When I say something is zero-sum, that when somebody wins, there's a loser. So like budgets are zero-sum. In order to pay for, we only have $100. in order to pay for this weekend's activities, we're going to have to not do something else, right? It's not unlimited. It'd be great if budgets were unlimited, because we could both build more roads and have public transportation. But unfortunately, it doesn't work that way. Coastal's transportation budget is limited. So we have a choice. We can have more shuttles, but having shuttles comes at the expense of parking decks. Parking decks are multi-story structures that you can drive a car in and park them. We can't. They're ridiculously expensive. That, and it'd be hard. I mean, I'm not going to say that it'd be hard to build because we just built a giant football stadium, and that's clearly not going to sink into the ground. But it's extra expense than just pouring some concrete because of the low water table. So they're more expensive here than they would be someplace else. Or we can buy more shuttles and you can park farther away and get shuttled in. And we can have an app and you can wait like 10 minutes or 3 days to get someplace. Right? So that's zero sum. In politics, people often think of rights as zero sum. And so I argue with people all the time because I teach con law. I got a friend, Jeremy, who insists that bakers should be able to discriminate against people because of gay weddings. To me, like, did the baker show up to the ceremony? No. Did the baker perform the ceremony? No. Did the baker do the first dance or give away the bride? Like, I just do this all the time. Every once in a while, I just shoot him a text. Hey, did the baker do this at your ceremony? No. But he sells cakes. I'm like, yeah, that's what he does. He sells cakes. So the fact that gay marriage exists doesn't mean that all of a sudden people are going to be forced to be gay. It's kind of like broccoli. Either you like it or you don't. And he's a political scientist. It's like, dude, think of it this way. No. Religious liberty. Nobody's persecuting you. We're just saying you're baker. Bake the freaking cake already. The problem is, in my exchange with Jeremy, is that he's fallen into this trap of the difference between what is an empirical question, and empirical is just fancy college speak for evidence-based, and a normative question. Normative questions are not opinion-based, but they're not evidence-based, they're opinion-based. And you end up with things like should. Should questions. We have to avoid these types of should questions. Should questions we don't do in political science or social science or statistics. Should the United States invade Iran? That's a normative question. That depends upon what your preferences are. That's not a social science question. And you can analyze what would happen if we invaded Iran. But again, those are normative questions, and statistics can't answer those. Should a baker be forced to bake a cake? That's what they want to do. Like, if they don't want to bake a cake, then don't be a baker. I don't understand this. There are lots of people who live in this normative world where there's this constant struggle between right and wrong, and they come up with concepts like justice and liberty and freedom. Like, that doesn't involve statistics, because you're naming concepts that I can't measure. Actually, that's wrong. I can almost measure anything. But you're focusing on this idea rather than evidence. So don't do that. Don't be one of those people. So let's talk about the scientific method in the last half an hour. First step, you need to develop a research hypothesis. Now, a research hypothesis has to have two things in it, an independent and a dependent variable. And what your research hypothesis is doing is telling me about the relationship between the two variables. Now, what do I mean by variable? Well, again, we have to have a common set of vocabulary in this class. A variable is a property, characteristic, construct, concept that can take on different values. Your variables must vary. So let's think of a variable about the people in this room that does not vary. Like, give me a bad variable. She says we're all students at Coastal Carolina. Are we all students at Coastal Carolina? What classes am I taking? You excluded me. I don't matter. Son of a bitch. If I don't matter, I don't need to be here. So are we all students at Coastal Carolina University? No, that's a good variable. We're all present. Yeah, we are all present. That's true. Everybody's awake. That would be a bad variable. Give me another example of a bad variable. Attempting to measure differences in which there are none. We're all human. Are we all human? Anybody want to claim something different? Are we all from Earth? Are we all alive? Are we all breathing? Okay. Those are bad variables. Let's turn the breathing one into a good variable. So are you breathing? Yes or no? We are all clearly breathing. Also really hard to answer if you're not breathing. But let's turn that into a good variable. How do we measure breathing? Anybody here ever had their breath measured? I can't hear. The fan's really loud. Try again. Breaths per minute. Okay. So how many times do you breathe? What is your rate of respiration? That's one way. How else can we measure breathing? Anybody here ever have asthma as a kid? Remember blowing into the tube to see how high the ball goes? Like the capacity that you have in your lungs. That's another way in which you can measure breathing. Test anxiety. I can come up with a list of symptoms. Everything from what's a test? Is that today? That'd be pretty low test anxiety. To I'm not going to make it to the test because I just crapped my pants. Right? That'd be pretty high on the list. Or I refuse to get out of my bed today. That's my level of test anxiety. If you need me, I'll be under the covers. Panic attacks. High levels of test anxiety. Those exist. I can measure that. Exposure to violence. Oh, my wife and I have this discussion all the time if the kids should be playing Fortnite or not. And I'm like, it's a video game. They're like, yeah, but they shoot other people. I'm like, have you seen Star Wars? Like, lots of people die. Even the robots. Roger, roger. Like, the droids just get demolished every time. Parenting styles. This is where my example for the class in the data videos comes up, right? Should we spank children? You instantly started nodding your head like, hell yeah, we should spank children. Little bastards. What you should do is threaten to spank your children, let them think it's coming, but don't actually do it. That's the approach I've taken. It's like, do you need a spanking? Oh, no. I'm like, all right. I'm not going to abuse my children. Come on. amount of exercise to no thank you, to how many hours a day, how many calories you burned, how many points you earned on your Fitbit or other device. Like it's a competition or something. Like not only do I have to exercise, but I have to earn points. How many steps I walked. Which I have a question about. How do you measure walking on your wrist? Yeah, so if I just do this a lot, I'm running right now, according to my Fitbit. I've earned extra 10 points. Or your phone? Yeah. What if I like to run in place? I'm one of those people. Okay. Where does your research hypothesis come from? Well, it should come from you, first of all. Like you should have a genuine curiosity about something. Because that's when you're most interested in it and you'll actually do it. Like Sudoku. I don't understand what Sudoku is. Like it's just writing numbers on in a grid, but some people are like, no, this is really good. Like this does not look like fun to me. But some people find it fun. When you're picking a topic to do research on, it should be interesting to you. So that way you'll want to do it. Since you have to do it for this class, you might as well pick something that's interesting to you. There's a point in graduate education where basically whether or not you're going to finish and get your PhD comes down to your ability to find a question that you're going to write a book on. And that was something I kind of struggled with. The things that I was interested in weren't all that interesting to other people. And so I was talking with a mentor and I said, Scott, tell me where your dissertation came from. And his answer was, he grabbed a book, he opened it up, and he said, I disagree with this. He read a sentence, said he disagreed with it, formulated a research hypothesis from it, wrote a dissertation, and then eventually published it as a book. Because he disagreed with what somebody said in a book. That was not helpful. He just like stumbled over it. But that's why when we ask you to do the research writing process, that we teach you to do things like a literature review. English, sometimes they call them an annotated bibliography. The idea where you have to summarize what somebody else wrote. It's a good idea to know what the conversation is around that question. You have to do some research on your research. You have to know what people are saying. In your research question, I told you you have to have two things, an independent and a dependent variable. We know that variables have to change, but what independent and dependent variables are, that's kind of a tricky thing for undergrads. And if you get lost on this, you're going to be lost in the entire class. So an independent variable is the variable that can be manipulated by the researcher in a classical experimental setting. Let's see what happens when I light this on fire. Let's see what happens when I put this in water. The variable that is manipulated by the researcher. It is your cause. The dependent variable is the variable measured by the researcher. It is the outcome. It is the effect. So what's just been happening in this room for the last 45 seconds? I flick a switch, then the lights go on and off. What's the independent variable and what's the dependent variable? The theory is that when you change the switch that the light in the room changes. We all agree with that? Well, if that's true, let's try these switches. I just did all 4 of these switches. The lights are still on. Got a problem here. All right. The switch causes a change in the light. There's a process to it. That's our theory. One is a cause, one is an effect. One is an outcome. Right? Your dependent variable. So here are some examples from the book. The research question is student performance on tests influenced by motivation or learning strategies? Okay. So the research hypothesis, that's the research question, right? What happens? The hypothesis is going to state a expected relationship. Students who are taught effective learning skills will perform better on tests than students offered incentives to do well. How can you tell the difference between a question and a hypothesis? Notice that the hypothesis has an outcome. It tells us what it is we're actually going to be looking for. So in that first example, what's the outcome or the dependent variable? What's that? Read it literally for how it's written. What is the outcome? Yes. The outcome is performance on a test. That's the dependent variable. What's the independent variable? What they're taught. If you're taught effective learning skills, you will do better on the test. Taught skills, did better on the test. Right? Think of it in terms of a sequence. If this happens, then that'll happen. If you're born male, then you'll want to spank your kids. The research question, does gender and the difference in chemical compositions between men and women affect their views on parenting? That's the research question. Does the difference between testosterone and estrogen lead to behavioral changes? My research question is being male, does that make you more likely to support hitting children? How do parents' feeding practices affect whether their children will eat new foods? That's the question. Greater use of forceful feeding practices leads to greater food refusals. So if you just tell your kid, eat this now, are they going to do it? Or if you explain to them, hey, if you eat this, you will grow stronger, taller, whatever. Is that a better strategy? I try it. Right? John likes superheroes. You want to grow tall like a superhero? Drink your milk, eat your protein. Why? Well, milk has calcium, bones will make you grow taller. Protein is a muscle, you'll make muscles. Ta-da! That actually works. He's 6, he doesn't know anything. All right? But that's not a forceful practice. John, open your mouth, I'm going to shove this in there and you're going to eat it. No, it doesn't work. Trust me, I've tried. That's my brushing teeth routine. John, open your mouth. No. Does coercive interrogation of eyewitnesses affect their accusations of crime suspects? That's a question. If we do this, what will happen? The hypothesis is saying what the outcome will be. Coercive interrogation increases eyewitnesses' false accusations. So if somebody is coercing you to do something, you might just give them what they want so they'll stop. Are there gender differences in terms of who contributes to Wikipedia? That's a question. Does this thing exist? The hypothesis is women are less confident in contributing to Wikipedia than are men. So gender is the independent variable, confidence is the dependent variable. Step 2. Once you have your research question and hypothesis, you actually need to go out and get some data. This class, I've already told you where to go. It was that video you were supposed to watch for Tuesday on the SDA website. The SDA website houses large national omnibus surveys that have questions on them like, what are you, male or female? Do you think you should beat your children? Do you know anybody that's ever been murdered? It's in there. Right? For our class, the reason I like the General Social Survey and the American National Election Studies is because it's a nice, large sample. A sample is when you take a subset of the population. So you take a small group to represent a larger group. The population is everything. Every last person. Sometimes you can study a unit that you can get the population if it's sufficiently small, if it's known, you can do that. So in American politics, if you study the presidency, can you have data on the population of presidents? Why? Because we know who they all were. That's a kind of an important thing. And how many of them were there? Let's go with 45. Right? 45 people. So if I ask you to collect data on 45 people that are some of the most famous people in the history of the United States, do you think you could do that? Yes, you could do that. I know you could do that. It's been done before. Whether or not your data is a sample or a population depends on how you're examining your question. So here are some examples. College students. That could be the population, right? We could generalize about college students and how all you like to do is party and watch Netflix and not eat at the dining hall. You want to drive to your classes. I can go on and on if you'd like. But I can't talk to every college student. It's just not possible. I can talk to college students enrolled in my statistics class. You're my sample. So I'm going to draw conclusions off of my observations of you and your behavior. A population might be every registered voter. But to know who's going to win the next election, I can't talk to every registered voter. I can do a survey of registered voters in a geographic area, like a congressional district or a county, who agree to complete a phone survey and have a phone and answer the phone at that time. That's my sample. Are there any people who might not have a phone? Who? Homeless people might not have a phone. That's true. Anybody else might not have a phone? Children, but they wouldn't be registered voters. All right, old people might not have a phone. Or they just might not answer the phone. Actually, old people tend to over-answer the phone because they're just glad to have somebody to talk to. And you guys look at it and you're like, I don't know this person, and you don't answer the phone at all. Caller ID really messed up telephone surveying. It was really weird when it was a time where you had to watch how many minutes you had on your cell phone plan. Something this generation mostly doesn't know, but I remember that. I only have 100 minutes this month. They'd call and you'd be like, not this month. Not going to answer that one. Sometimes the difference between a population and a sample depends upon whether or not you're aware that you're a member of a population. So think about if you're a pharmaceutical company trying to treat depression. The population of people who need your treatment are people who are depressed. One problem with that is that sometimes people don't know they have depression. They just kind of think this is the way life is. Right? It's a diagnosis. So the sample are the people who have been diagnosed, which means you probably need to have some access to health care, and who want treatment. Sometimes we're sick and we don't want treatment. I have high cholesterol. You know what I do about it? Nothing. It's not good. It's a bad thing, actually. I do absolutely nothing about it. I just, don't like doctors. Yeah, I can't see it. Right? It's not like it's growing out of my head or something. Can't do anything about it. Well, I can, but I just choose not to. So this difference between a sample and a population, it's actually going to be really important for us in statistics. Because of the difficulty of getting a population, which is the whole point of going through this, is to basically show you that aside from like when you have 45 people that you know are world famous, it's really hard to get a population. So we're going to have to rely on methods that allow us to do a sample. And later in the semester, we'll talk about the proper way to eat soup. And this will all be revealed. And it'll make sense. So step 1, formulate a research question and a hypothesis. Step 2, collect data. So from those examples before, if you want to know about feeding practices of kids, 60 families who had a kid. That's a good sample. If we want to know about feeding practices, we get a bunch of people that have kids that have to feed them. Women are less confident in contributing to Wikipedia than are men. Who's the sample? 1,600 people who say they contribute to Wikipedia. Students who are taught effective learning skills. Who's our sample? 109 juniors and seniors enrolled in ed psych classes. Psychology has it great, 'cause lots of times they just think of a study and then they make the students take the experiment or be part of the study. So lots of studying students. Even the one about interrogation techniques, 60 university undergraduates studying psychology. So they had to sign up to be part of an experiment where somebody coerced them. So we've got our research question, we have our data. The next step is to analyze the data. That's what we're actually going to do in this class, is learn how to analyze data. But the way in which the scientific method works, this is where we get the most diversity. The idea in how you're going to examine, analyze, and all those other variables from our definitions of statistics. How are you going to do all of that? Generally speaking, I'll start with the most conventional way, which is an experimental way. Test for causal relationships among variables. So every time I hit this button, I want to know what's going to happen. Now I've got this one figured out. Lights go on, lights go off. Got that one figured out. This one over here, I don't know about. What's going to happen when this? Because there's numbers from 1 to 4. And I think 1 to 4 is like a progression. Like maybe as you go from 1 to 4, it gets continuously darker or brighter. I'll really take either one. But it doesn't actually work that way. So really, I'm experimenting every time I come over here, push the button and see what happens. Could I measure light? Okay, that's the difference between 2 and 3. So 1 was everything's on. 2 is a few things are on. So I've gone from 1 to 2. I've gone to less light. So if I hit 3, it should get darker in here, right? Damn it. It got brighter. University professor, PhD, ridiculous number of years of education, and I don't know how that light switch works. So in an experiment, we want to have control. This is a good control. It's got 2 options. I can't control that light switch. I don't know how it works. What we attempt to do is to treat the conditions of the unit, the person, the respondent, the same, and figure out what's different. So that's why when you look at the General Social Survey, you'll notice that they ask people hundreds of questions, including, do you know somebody who's been murdered? Why? Because that's a control variable. It might influence your thoughts on things like policing, the death penalty. We can have that as a control. The perception of science as being in a laboratory, the laboratory is the control. You control the environment. Then there's other stuff. I'm not going to really go over all this yet because we're not there yet. This is really the part that we need to know in the last, what do I got, 15 minutes? Is that what I have? Okay. In this class, we're going to learn how to analyze the data that we collect. 2 main functions in analyzing data. One is descriptive statistics. That's the first part of class. It's part 1. We're going to learn methods to take our data sets and organize them, summarize them, describe. After all, it is descriptive statistics. So in chapters 3 and 4, we're going to cover things like measures of central tendency and variance. So, anybody here like a junior or senior? Ha. You'd think I don't matter. I'm not talking to you. Okay. So, at the end of the semester, you go home. People ask you, how's college, this or that, right? You ever get the question, how are you doing? Yeah. What do you tell them? Fine. Okay. And then they go, well, how fine? How do you answer a question like that? You don't? Okay. Non-responsive. Does anybody answer that question with the statistic, perhaps? Pardon? Medium rare? Okay. You're home. Dad wants to know. All right, how was school this semester? I need to know to decide if I'm going to send you back. What's one descriptive statistic that you can tell Dad very quickly to get him to agree to send you back? There you go. What is your GPA? No. Let me rephrase that. What is a GPA? Sorry. Okay, it's your grade point average. That's I was just trying to get you to actually say grade point average. Okay? Your grade point average. Why would you say your grade point average? You think it's a reflection of how you're doing. Okay? Why don't you just say, well, in fall 17, I got an A, a B, a C, an A, and a B+. In spring of 2018, I got a C, a D, an E. Wait, E's aren't even a thing. Right? Why don't you just list all your grades? A, it's more work, and B, there's this thing that exists called GPA that takes all of your grades, assigns them a grade point. That's what the GP and the GPA is. So an A is how many points? 4. And it averages them all together. That's a descriptive statistic. You have to calculate that. I'm actually going to spend an hour teaching you how to calculate a mean, which is a fancy science word for average. Yep, because it's a measure of central tendency. You can't do a lot with those statistics. You really can't, right? It doesn't, it tells me what the data looks like, but it doesn't tell me what the data means. So then in the second part of the class, we're going to learn about what are known as inferential statistics. We're going to test hypotheses, draw conclusions. The reason that we want to do this is because we want to be able to generalize about the population from our sample. So we want to be able to say, I've looked at these 20-something students of Coastal, and I have found that by attending class on Thursdays, their grades are actually higher. So what am I going to do with that conclusion? I don't know. I'll spend more time on you guys because you'll actually learn something. Those Tuesday kids, they didn't take the Thursday class because they want to have a longer weekend. Screw them, they're not as interested. There we go. I'll generalize about the population from my samples using inferential statistics, which is where we talk a lot about probability theory and how is it that we know whether or not we like soup. It's coming. Last step in the scientific method, draw a conclusion. For us, drawing a conclusion is going to be making a determination about whether or not our sample does reflect the population or not. We need to be careful, though, because I don't know if you're aware of this, but people out there, they're looking for truths. And sometimes they look for truth from science. which you're going to be sciencing, right? You're going to be writing a paper. You're going to be drawing a conclusion. People out there actually believe what you say. I get asked to be on TV and talk about politics. Why? Authority, right? I have a PhD in political science. People think I know something. I've published on topics, so therefore they think I know something. I did a TV interview one time. It was in the 2012 election, and it was in South Carolina. It was one of the first primaries. And I did like a morning show thing, so I was a little sleepy still. And the person live TV too, so I got to remember not to swear. The person asked me, "Hey, we just found out how rich Mitt Romney is. What do you think about that? Do you think that'll help his campaign or hurt?" And my answer was, we already knew he was rich. And that's it. But the person wanted me to comment on what will be the effect of this new information. And my response was, we already know this. And I just sat there. And he had to think of another question to ask because he expected me to go on about all of this stuff. And I'm like, we already knew this. It'll have no effect. Anything else? No? All right. Can I leave now? I want to be here. When we turn to social science or even the hard sciences, we want an answer. But we don't have in social science the answer. So when we write up our results, we have to be very careful about saying whether or not we have proven something to be true. In social science, we don't prove anything. We can find support for an argument, or we can find support for a theory, but I've not proven anything. We have to focus on whether or not the results are in line with what we expected. Our expectations can come from theories on how the world works. It can come from previous research that has demonstrated something similar. But we're not like chemists or engineers. When I talk about the light switch, pushing the button leads to a change in the lights. And if I just keep doing it, eventually I'll prove it, right? Like, oh, you want the lights on? You have to push the button. But is that really what's happening? For me, I have observed me pushing the button. Apparently I don't know how to push a button. And I have observed the effect. But is it the button pushing that's turning the lights on and off? To me, yes. To an electrical engineer, no. That's not why the lights are going on or off. The electrical engineer is going to talk about circuits and the role of the switch in completing the circuit to allow the current to flow. Or apparently with this switch, we need like a computer programmer to say which switches will work with which lights and if they'll go on or off or whatever. I've actually written a very large email complaining about the light switch. Not unsolicited. Actually, they bumped into me. They're like, hey, you teach in this room. Can we ask you some questions about the room? I'm like, sure. Can we go to the light switch? I would like to answer questions about the light switch. And so for like half an hour, we talked about the light switch. We talked about how a professor uses the room. They said, this is all great information. Will you write it up for me? Yes, I would love to write it up for you, because that's what I do. I write things up and tell you what you should do. I wrote up a very long email. I came back the next semester. They changed the light switch. They made it a button. Before it was a touchpad. It was a touchpad, 1, 2, 3, 4. They actually now, it's a button. Still does not do anything to the lights in any predictable form or fashion. But they changed the buttons. So I got that done. Why go on this tangent about light switches and the epic email I wrote? Because that's the last step in the scientific process. Once you've found something out, you have to figure out a way to communicate it to other people so that they know. They now know what the outcome is. I clearly did a poor job in communicating my findings about the light switches. Clearly. Because I told them 1 should be all of the lights, 4 should be none of the lights, and 2 and 3 should be a progression. That would be helpful to me. Or vice versa, whichever way you want to do it. You clearly need to change the button. Change the switch. And they did that. They changed the switch from a touchpad to a button. Still programmed the exact same way. And fun fact, the 4 button switches are programmed differently in every room in this building. So if I know I want to walk into a room and I want to turn the front lights off but leave the back lights on, I push all of the buttons to find out which program that is. Because it just can't be number 3. This is your job as social scientists. You've done a study, you have some findings, now you need to share them with the world so that people know. Or turn it into clickbait and sell more chocolate. Your choice. Really, it's up to you. But that's actually the scientific method, and that's what we'll try to go for in this class. Any questions? We good? All right. She's leaving, so we're done. Have a good day.